Okay, so this video is optional for you guys to watch, but it is here if you want. We are going to start with the two problems that are in vertex form because this is what you should be familiar with already. This is on page 9 in your math notebook. Okay, so first I'm going to start with my vertex. My vertex is my H and my K. And then the vertex, we always do the opposite. So my H here is 2, but the opposite of 2 is -2. And then my K is 3. My axis of symmetry goes directly through my vertex, and it's my X point. So my first number is my X, and that is -2. This is going to open down because my first one, A, is negative. So we're going to say this opens down. The y-intercept, let's scroll down a little bit, is when x is 0. So I'm going to substitute in 0 here. So we get y equals -2, 0 plus 2 squared plus 3. 0 plus 2 is 2. 2 times 2 is 4. 4 times -2 is -8. And then -8 plus 3 is -5. So this is my second point that we can use, our y-intercept. So different points that we have our y-intercept, and then if we wanted to have one more point, we can go either left or right of the vertex with the slope, and our slope is technically our A, but that only works for one point because it is a parabola. If you were to do it for 2 points, and then for your third point and for your fifth point, or whatever, it would end up being a absolute value graph. So it would look like a V instead of a U. So let's take a look. We're going to put this on our graph. Our vertex is -2, 3. So -2, 3. We can draw our axis of symmetry down the center. We know it's going to open down, and it also has a y-intercept of -5. Because this is 2 spaces away from the axis of symmetry, I can put an identical point on the other side, 2 spaces away. And then again, if we wanted to do that additional point, we would start at the vertex, and we would go based off of our slope, if you want to call it that. You can't see me, but quotation slope. So our slope is technically, for one point, is -2 over 1. That is a rise of -2 and a run of 1. So starting from the vertex, down 2 to the right 1. And again, axis of symmetry divides it right in the middle. So if it's 1 space this way, it is also 1 space to the left. And that is enough to draw our parabola. So this one is all done. Oh, and then if we wanted to put those 2 points, we could. That is -1, 1 and -3, 1. So -1, 1 and -3, 1. Okay, the next one, we look for our H and our K. I'll do it in a different color. Our H, it looks like -4, but we always do the opposite, so that's a +4. Our K is -3. It is actually -3. This is going to open up because our first number is positive. Our axis of symmetry goes directly down the vertex, so that is based off of our H, which is 4. Our y-intercept is when x is 0. So we substitute in 0. 0 minus 4 is -4. Use PEMDAS, do your exponents first. -4 times -4 is 16. Now half of 16 is 8. And then 8 minus 3 is 5. So this one also has a y-intercept of 5. The other one was negative 5. And then for our extra point, we would do the slope. This one has a slope of 1/2. So we're going to use that to find the other point. So vertex of 4, negative 3. To the right 4, down 3. Axis of symmetry goes right down the middle. That's your axis of symmetry. This one had a y-intercept of 5. So I'd count the boxes. 1, 2, 3, 4. It's a distance of 4 away. So 1, 2, 3, 4. And then for a slope of 1/2, we go up 1 over 1. Or sorry, up 1 over 2. And then same to the other side, up 1 over 2. So this is a fat boy. He is a wide parabola. And we would know that it's wide because A is 1/2 and 1/2 is less than 1. If it was less than 1, it would make it fat. If my A was greater than 1, it would have been skinny. Okay, now this one says write the equation in vertex form. So right here we have our H and our K, which is negative 4 and negative 2. The A, we would do a slope, so rise and run. So this one's a little bit hard to see. So A is positive because it goes up. And a rise and a run. This one goes up like a 4th. So if we subtract those two numbers, if we subtract 2 and 1.75, if I think of money, that's a quarter. So I can either write it as 1/4, or you can write it as 0.25, whichever one you like better. And then what else do we need? That's it. Our HK and then our A. Okay. So Y equals A. I'll use 1/4 times X minus H, but we have to do the opposite. So plus squared minus 2. Let's make that a better 4. Okay, this one, it is going down. So we know A is going to be negative. Let's see, how much are we going down? Rise and run. 1, 2, 3, and 1. 3 over 1. And then a vertex of 2 and 6. Remember that one, you make the opposite. So y equals negative 3 x minus 2 squared plus 6. And then, so these ones are currently in vertex form, but maybe we'll need them in standard form, depending on what you need. So I'm going to show you how to do that. You're just going to expand it. So 2 times x plus 1. This is squared, so that means there are 2 of them. So I'm just going to write 2 of them. And then you can multiply them in whichever order you want. You can do 2 times x plus 1, or if you want to do the x plus 1 times x plus 1 first, and then do the 2 after, either one would be fine. But I'm going to start with the 2. So 2 times x, 2 times 1, And then I like to do the box method. If you like FOIL, you can do FOIL, whichever one. 2x plus 2, x plus 1, 2x squared, 2x, 2x, and 2. We combine like terms. So 2x squared plus 4x plus 2. Now that is in standard form. That is ax squared plus bx plus c. Oh, and I forgot my y at the front. This one, same thing. If we want to change it from vertex to standard, we just expand it. So -1, make sure you're following PEMDAS. So let's do this one. -x minus 3, x minus 3. Let's do FOIL for this one. Why not? So -x times x is -x squared. -x times -3 is positive 3x. -3 times x is -3x. -3 times -3 is positive 9. And then don't forget the 4 at the end. All right, combine like terms. We get -x squared. Those cancel. 9, 10, 11, 12, 13. Okay, and then there was one last problem. This is the technically new way of graphing. We're taking standard form and then graphing our parabola. So if I want to find my a, that is the number in front of x squared. So that is -1/2. The 3 is by itself, so that's my constant. Does this open up or down? It is going to open down since my a is negative. My axis of symmetry, the way I do that is negative b divided by 2a. I'll do the work over here. So negative b divided by 2a. So -0 divided by 2. And then I already know this is going to be 0, but we can still simplify it. -1 and 0 is just 0. This makes -1. If I got 0 cookies and negative people, then we get 0 cookies. So my axis of symmetry just goes down the origin. We call that x equals 0. My vertex is my h and my k. Oh wait, this one you don't have your h and your k. That's in vertex form. So I'll show you how you get your vertex. My vertex has a 0 for the x, and then we substitute it into the rest of the equation. And 0 squared is just 0. And then 0 plus 3 just equals 3. This ends up being our y-intercept as well. Sometimes that happens, not always, not frequent. And then we say, is this vertex a min or a max? Well, if we draw it, we have a vertex of 0 and 3. It is negative, it is going to open down. And then we use, this explains over here, use A to find 1 points left and right of the vertex. Since the vertex is also the y-intercept, you can't reflect it across another to guide you. Instead, find another value for your x and then reflect it over the axis of symmetry. So again, do the slope. So slope, for this one, we have -1/2. So down 1, this graph is counting by half, so make sure you watch your graph. So down 1, to the right 2, and then same thing for the other side, down 1, to the left 2. Our axis of symmetry. And then again, this one's a fat graph because A is less than 1. So A right here is 1/2. I know it's negative, but we take the absolute value of it. And 1/2 is less than 1, so it makes it fat. If you guys have more questions, or if you want me to give you more questions,